Hi everyone, it's Mrs Jennison here and I'm an Associate Director for our Grange Academies Trust. Welcome to today's lesson. In today's lesson we are looking at displacement. Displacement is one of the lessons in our Mass Matters topic. We have previously looked at conservation of mass and what reactions produce gas. In today's lesson, we'll be starting to look at why some metals react differently and then looking into what displacement is. Our challenge for today's lesson is to be able to define the term displacement. Our aspire is to be able to explain whether a metal will displace another from a solution. So let's start with a quick recap from our previous lessons. I'd like you to name the acid which would be used to form each of the salts listed on the screen. Sodium chloride, lithium nitrate, magnesium sulfate, potassium sulfate and calcium chloride. Hydrochloric acid will be used to produce sodium chloride, nitric acid to produce lithium nitrate, sulfuric acid to produce magnesium sulfate, sulfuric acid to produce potassium sulfate, and also hydrochloric acid again to produce calcium chloride. Now, as we have seen in previous lessons and previous topics, all metals have different reactivities. Some react really violently with water. As you can see on the screen at the moment, this is one of the group 1 metals reacting with water, and it's a very violent, explosive reaction. Their reactivity with acid varies, as we saw in our lesson on metals and acid. And some metals are relatively unreactive, for example, gold. As you can see on the screen, it was used to create a tooth implant for a tiger who had a cracked tooth. And also, I'm sure you have seen the film that scene is from. Gold maintains its shininess because it doesn't react with oxygen in the air. Now, a displacement reaction is a reaction in which a more reactive metal can displace or push out a less reactive metal from a solution of a compound. So that can be seen in the image on the screen. The copper is more reactive than the silver in the silver nitrate solution it's been placed in. So the copper swaps places with that silver, and you can see the silver form as a solid on the outside of that copper. So an example of this would be if I placed iron in copper chloride. Iron is more reactive than copper. So it will displace the copper from the solution. That will leave me with some copper and iron chloride. So the metals have essentially swapped places. And this is because the iron was more reactive than the copper, which is in the compound. So iron forms iron chloride and displaces the copper, which will form as a solid. In the test tube is a solution of copper sulfate. We're going to add some strips of metals to that copper sulfate and see if the metal displaces the copper out of the solution. We'll then record whether it reacted or not, and then repeat that reaction with silver nitrate solution. So the first metal I'm going to add is magnesium. Then I'm going to add some zinc, some iron, and some copper. Now you can see already that the magnesium is fizzing and reacting quite vigorously with the copper sulfate solution. And the zinc is also reacting quite quickly. The iron is reacting but slightly slower. So we'll leave them for a short period of time, and then I'll pour out the copper sulfate solution so we can have a look at the metals. So first, if we look at the magnesium, we can see that the colour has changed completely compared to what it looked like at the start of the reaction. That's because some copper has formed on the surface of the magnesium. So magnesium has displaced copper from its solution. And the same has happened with the zinc. So the zinc now has a very different appearance to what it did at the start. Now, both of those have quite a significant amount of copper on them. There is a thinner layer of copper on the iron nail. So whilst iron is more reactive than copper, it's not quite as big of a difference in reactivity than the other two metals. And obviously, there is no difference in reactivity between copper and itself. So there is no change seen on that test tube. So now I'm going to repeat that investigation with a different solution. So in the test tubes now, I have silver nitrate solution. So now we should see if the metal is more reactive than silver. So if I add my piece of magnesium, then I add my zinc, then I add my iron, and then I add my copper. And we'll just leave them for a little bit to see if they react. So this time I've not actually had to pour out the solutions for you to see the change because silver nitrate is a colourless solution. So as you can see, there are some crystals forming on the magnesium, and they are crystals of silver. So magnesium's more reactive than silver, as is zinc. We can see the colour change on the zinc very clearly as well. As is iron, again, there's your colour change on the iron. But this time we also can see a colour change on the copper, which shows us that copper is also more reactive than silver, as it has displaced it from its solution. Now, this reaction could also be performed in a spotting tile. And if you were to do this in school, it would be more likely that you would do it in this context. So to each spotting tile, you would add a few drops of copper sulfate. And then if you added a small piece of metal into each of those dimples, you could note down whether the metal changed colour. And by changing colour, it's showing us that it displaces the copper. Now, metals can be placed in order of reactivity from most reactive to least reactive. And this is something we will be working on in another lesson when we start to look towards our project. However, for today, you may want to use this in some of the following tasks. There is a copy inside of your planner, and I have also placed one on the screen for you now. Now, I'd like you to have a go at figuring out whether some of these examples would displace or not. And if they would, I'd like you to complete a word equation for that. Now, remember, for a metal to displace another one from a solution, it has to be more reactive. So iron would displace copper from copper sulfate, so you would form copper plus iron sulfate. However, gold is less reactive than copper, so this would not react. There would be no displacement here. Magnesium is more reactive than copper, so we would have copper and magnesium sulfate form. And copper are both copper, so there's no difference in reactivity, so we would not see a reaction there. Zinc is more reactive than copper, so this would form copper and zinc sulfate. And aluminium is also more reactive than copper, so this would form copper and iron aluminium sulfate. So we're going to do a little quiz to check your understanding of everything so far. It will be a true or false quiz. I'll read the statement, pause for you to think of your answer, and then really reveal whether that was true or false. So the first one, a less reactive element will displace a more reactive element. And that is false. It's a more reactive element that will displace a less reactive element. Copper is more reactive than iron. Again, that is false. We saw that in our example video where we watched the reactions of these metals. Magnesium is more reactive than copper. And the answer for that one is true. Magnesium is more reactive than copper, and that would displace copper from a solution. Copper is more reactive than gold. And the answer for that one again is true. Copper is more reactive than gold, so gold would not displace copper from a solution. So now it's time to have a go at some exam questions on this topic. Harry mixed zinc with copper sulfate solution in a test tube. A displacement reaction took place and the temperature increased. Now that's an indication of a reaction occurring, as it would be very difficult for you to see a colour change on a black and white question. The word equation for the reaction is shown below. Zinc plus copper sulfate forms zinc sulfate plus copper. Why is this reaction called a displacement reaction? Harry repeated the experiment with two other metals. He wanted to calculate the temperature rise each time. His results are shown below. Harry used different starting temperatures. Explain why this did not affect his results. Part of the reactivity series of metals is shown below, so they are ranked from most reactive to least reactive. Use the reactivity series above to answer all of the questions below. So the first one is, why was the highest rise in temperature obtained with magnesium and copper sulfate? And the second one is, why was the rise in temperature obtained with zinc and copper sulfate not much higher than the rise in temperature obtained with iron and copper sulfate? So again, the reactivity series is placed at the top of the screen, and that can be used to answer the third question, which is, in which of the following mixtures would there be a rise in temperature? And to just indicate by saying yes or no. So now we're going to go through each one of those questions so you can check your answers. So for the first one, they asked, why is this reaction called a displacement reaction? And it's because the zinc is displacing the copper from the copper sulfate, or you could have said it's changing places with the copper. A few other acceptable answers are on the screen now. So then you were given some results and asked why it didn't matter that Harry used different starting temperatures, and it's because he only needed to find out the rise or the change. Because he was finding the change in that temperature, it doesn't matter that he had a different temperature at the start, because it's the change that he's using to compare. So then you were given a reactivity series, and the first question was, why was the highest temperature rise obtained with magnesium and copper sulfate? And that's because magnesium was the most reactive metal used in that investigation. But you could have also said it's because it has the biggest difference in reactivity between magnesium and copper. And then the second question you were asked on that reactivity series was why the rise in temperature obtained with copper and zinc was not much higher than the rise obtained with iron and copper sulfate. And it's because they're next to each other in the reactivity series, so there's not as big of a difference in reactivity. Then you were asked which of the following mixtures would show a rise in temperature. So you wouldn't see a rise in temperature for aluminium and sodium chloride, because aluminium's less reactive than the sodium. For calcium and zinc, you would, because calcium's more reactive than zinc in the zinc sulfate. Lead and zinc chloride, you would not get a rise in temperature, because lead is less reactive than the zinc that is in zinc chloride. And magnesium and iron chloride, you would get a rise in temperature because magnesium is more reactive than the iron in iron chloride. So that is everything for me this lesson, and I will see you soon.